SimCar was developed by a group of UC Berkeley Engineering students. SimCar's goal is to make the lives of car rental companies easier by providing them with simulation software in order to optimize their inventory. The car rental company industry is $34 billion strong in revenue. It grows at an annual growth rate of 1.3%. The competitive landscape of the market is a bit different from other markets. It's split across the major players fairly equally, with Hertz having a slight edge with 28%. The cost to acquire or lose customers is fairly low. The deciding factors for why a customer goes with a particular car company are the insurance policy offered, customer service, vehicle quality, car variety, of course price, but most importantly, availability. Getting the type of car a particular customer wants is no easy task for a car rental company. They have to deal with inventory management, cars are picked up from one location and dropped off at another, free upgrades, lack of ability of particular car classes may force the company to upgrade for free, seasonality, inaccurate demand seasonality forecast affects supply and availability. These three factors can all contribute to loss of revenue for a car rental company. So the solution for all these problems? SimCar.
This is a simplified ERG for SimCar. The simulation starts with the user defining the batch transfer size, car types, number of locations, and the yearly growth rate. The user also uploads relevant data. Afterwards, the vendor rental locations are sorted based on the proximity to each other. This will later be used when the batch transfer cars is required. Subsequently, arrivals happen for each car type at each location based on user-specified arrival rate. If the desired car type is not available, we check for a possible upgrade to a higher class. If not, we reject the consumer and keep track of the relevant data. If a car is available, we rent the car out. If the inventory for a certain car type at a location falls below a user-specified threshold, we look at the nearest possible location that has the available inventory for batch transfer. The car is returned to some vendor location after a delay.
One of the great features of SimCar is its inventory management system. We give customers lots of flexibility in how to model inventory, including adjustable thresholds as to when they should transfer cars between different locations, and batch size transferring that's adjustable. Another one of SimCar's features is demand and seasonality modeling. This gives car rental company customers a lot of flexibility in how they choose to model their overall system. Another one of the great features of SimCar is its robustness. It can model up to 50 locations for car rental companies. It has a user-friendly interface for on-site issues, and it's cross-platform. But most importantly, it presents the data in an organized fashion for easy analysis. Another great thing about the way we chose to develop SimCar is its scalability. The model can be adapted to different industries that also require inventory management, such as the shipping industry. It can also be adapted internationally or even applied to the ever-growing popularity of car-sharing business plans. We built our models with flexibility in mind. And now for our model.
So each user is greeted with a sign-in page. This sign-in page allows people to look back at previous graphs that they created and analyze things historically. Each user then inputs their email address and connected password and are then greeted with our start page. So let's get started. So to start the simulation, we're initially going to run for 100 hours, and then we're going to start choosing the files that are required for the simulation to occur. First file is the distance, and this can either be chosen by dragging and dropping onto the file or clicking on the file itself. And currently our full version capability supports up to 50 different locations, so 50 different cities would be allowed. Next, we input the arrival rate for each different car type at each city. Then the starting inventory of each car type at each different city will be inputted. Next, we input a transition matrix that displays the probability of a car being picked up at location I, either returning back to location I or going on to a different location J. The use time is decided on the distance between two cities divided by the average speed plus a random number generated by a user-given beta distribution. If it returns to the same city, then the use time is simply a random number generated from the beta distribution. Next, the threshold value of each car type is picked. If the inventory drops below this threshold, the system checks for close-by locations that have excess inventory of that car type and then transfers those cars over. Since different times of the year have different demands, we give users the option to add monthly seasonality. In this specific simulation, we're running for only 3 cities, so the number of locations is 3. Next, you input the different number of car types that you have. Furthermore, the batch size of cars that are supposed to be transferred whenever a city falls below the threshold level. Finally, the growth of car rentals percentage-wise per year will also be taken into account in the simulation. So now that we've inputted all this information, let's run the simulation. Alright, so the first thing to see is that the results page is an easy to read, clutter-free page where only the important graphs are shown. Our first graph provides an inventory of every single different car type at location 1 versus the time and hours that have passed by. Furthermore, more specific points can also be highlighted just by clicking or moving your mouse over the graph. Similar graphs for inventory are shown at all the other different locations that we picked, but the most important thing is the number of rejections that the car type actually had. So in this case, there were 6 rejections in total. It should be important to say, however, that our future releases of the model will also provide information on the rejections at specific locations and of specific car types, not to mention the number of upgrades that were required at all these different locations. Also, to remind the user about what exactly the run parameters are, there's an easy to click button around the top right corner. This then displays all the parameters that were chosen.
You can contact us at admin@simcar.com.